Hello students, welcome to the fourth lecture of this series on renewable energy sources. In the previous lecture, that is in the third lecture, we understood solar energy, its advantages and limitations. Along with that one, we have studied solar radiations, in which we have understood what is meant by radiations, what is meant by solar radiations, thermonuclear reaction, especially the fusion reaction, and solar spectrum. Today, in this lecture, we will study availability of solar radiations on the earth, seasonal variation of solar radiation on the earth, and solar constant in somewhat details. So let's begin with availability of solar radiations on the earth. Incoming solar radiation received on the earth is known as insolation. Many times a definition is asked what is meant by insolation. So it is incoming solar radiation received on the earth is known as insolation. The word insolation is designed from incoming solar radiations. The change in insolation received by the atmosphere is due to the orbit of the earth during the year. As we know that sun is at fixed position in the galaxy and earth is revolving around the sun in an elliptical orbit. The gases present in the atmosphere are transparent to solar radiations. The radiation is nothing but the electromagnetic rays. As we know that the electromagnetic rays travel through a vacuum with the speed 3 into 10 raised to the power 8 meter per second. Electromagnetic spectrum is consist of gamma rays, X-rays, ultraviolet rays, infrared, visible red, microwaves, etc. Gamma rays and X-rays and small amount of ultraviolet rays are absorbed by ionosphere. The remaining amount of ultraviolet rays are absorbed by ozone layer. As we know, the ozone is designated by a symbol O3, means it have a 3 atoms of oxygen. Infrared radiation is completely absorbed by carbon dioxide and water molecules present in the lower atmosphere, while the visible light is scattered in all directions due to dust particle and gas molecules present in the dense atmospheric layer. Some of the radiation going back to atmosphere while other reach to the earth's surface. The scattered radiation reaches to the earth's surface is called diffuse radiation. The annular total solar radiation on the horizontal surface is highest near the equator. It is higher in sunny desert area. In winter season, the amount of solar radiation is lower than summer season. Solar radiation reaches to the earth's surface directly is called direct radiation. The sum of direct radiation and diffuse radiation known as global radiation. I again repeat the definition of global radiation. The sum of direct and diffuse radiation known as global radiation. Small part of total solar radiation come on the earth's surface. This small portion of solar radiation on earth is of great importance. It is the only source of energy on the earth. It is expected that global radiation received on the earth is 2 into 10 raised to power minus 9 times that of solar radiations. We will study the next topic, that is seasonal variation. Because of eccentricity of Earth's orbit around the Sun, the distance of the Earth and Sun changes. So energy received by the Earth's surface changes, bringing seasonal variation. Due to the movement of Earth around the Sun in an elliptical orbit result into seasonal variation, which ultimately reflects the amount of solar radiation received on the Earth. The amount of radiation depends on the duration of day. The radiation is more for longer duration of daytime, and their intensity together decides the amount of radiation received by the Earth. Definitely it is higher in the summer season, that is right now, and it is quite lower in the winter one. The amount of solar radiation reaching in the Earth's surface is affected by clouds. Clouds itself absorb some radiation will be scattered, and some radiation will be reflected by cloud. This will be happen or frequently happen in rainy days. The amount of solar radiation reaching Earth's surface depends on the duration of cloud cover, type of cloud cover, distance from the Earth's surface. So all this factor decides the amount of solar radiation received by the Earth. And lastly, we will discuss about the solar constant. Solar constant refers to the radiation energy falling on a surface perpendicular to the sun rays before any absorption or loss in the atmosphere. It is observed that the energy flux from the sun outside in the Earth's atmosphere is nearly constant. So, solar constant is defined as the amount of energy received from the sun in unit time on unit surface area perpendicular to the sun rays at the outer edge of the atmosphere at the mean distance between the Earth of the atmosphere and the sun. There is one mistake in the PPT, that is distance between the at the main distance between the Earth of the atmosphere. That sentence is repeated. The value of solar constant is approximately 1370 watt per meter square. W indicates the watt, that is the unit of power. The energy received by the Earth's surface is only 0.3 calorie per centimeter square. The availability of this much radiation is utilized to sustain biological life for an operation of different physical processes on the Earth. It is estimated that the diameter of Sun is 1.39 into 10 to the power 6 km, and that of Earth is 1.27 into 10 to the power 4 km. The next point is spectral distribution, that is solar spectrum. We have already defined what we mean by solar spectrum. So spectral power distribution. Spectral power distribution means a graphical representation between solar wavelength and power contained in the solar radiation. A graph is plotted in between solar wavelength on x-axis and power contained in the solar radiation on y-axis. The graph is as shown in figure. Spectral power distribution is affected because solar radiation will have to travel through atmosphere before reaching the Earth's surface. In this spectral power distribution, we have divided this graph into three different categories: the wavelength, in between 250 to 400, approximately 400, is known as the ultraviolet region, that is UV region. The wavelength in between 400 nanometer to 700, that is called as the visible region, and the wavelength above 700 nanometer is called as the infrared rays. The yellow indicates the sunlight at the top of the atmosphere. As from the graph, it indicates that in ultraviolet rays, as the wavelength increases, graph is fastly increasing up to a certain wavelength in visible, and then increases exponentially and comes to 0. Okay. There is an absorption bands of CO2 and H2O in infrared radiation. We have already studied that one. CO2 and water vapors absorb the infrared radiation in last slides. The spectral power distribution is affected because solar radiation will have to travel through the atmosphere before reaching the Earth's surface. So, the concept of air mass indicates the way in which solar power distribution is measured. Air mass is the concept, indicates the way in which solar power distribution is measured. If the solar power distribution of solar radiation is measured before Earth atmosphere, then it is said that air mass zero distribution. It means that solar power distribution of solar radiation measured before reaching the Earth atmosphere, then air mass is equal to 0. If solar power distribution of solar radiation measured on the Earth's surface, then it have some value. When the solar radiation makes an angle theta to the zenith, then air mass is defined as the ratio of the length of path under this condition to the length of path when sun is at 0, which is given by air mass is equal to 1 by cos of theta. If we assume that theta is equals to 60, then air mass comes out to be 2, that is indicated by AM2, air mass 2. Using Wien's distribution law, the maximum wavelength of emitted spectral line at a particular temperature is given by lambda equals to 2897 micrometer upon T, that is temperature in Kelvin. When we put the value of T is equals to 600 Kelvin, that is the temperature of the sun's surface, we will obtain lambda equals to 0.48 micrometer. This indicates that out of total solar energy, maximum amount of energy is within very small region of visible region, which is indicated by the previous graph, that is maximum energy lies in the visible region. That's why ultimately we are safe from this ultraviolet radiation and infrared radiation, while the value of infrared radiation is increases in summer. That's why we are facing the heat problems, while the maximum spectral power distribution, the value of maximum spectral value is found out to be in visible region, and therefore we are quite safe. So spectral power is maximum at wavelength 0.48 micrometer. The maximum amount out of total energy is within very small region of visible region, that is indicated by the previous